So last class we talked about classifying triangles, and we talked about what it means to be congruent. And in order for two shapes to be congruent, they have to have the same shape and the same size. So before today, in order for our triangles to be congruent, we had to have all 6 pieces congruent. We had to have all 3 sets of angles congruent, and all 4 sets of sides, all 3 sets of sides congruent. But let's say that we had a problem that looked like this. So let's say this triangle had 60 degrees. Let's just go 40 degrees. And let's say that this triangle has 60 degrees and 40 degrees. And this one's congruent, that's congruent, that's congruent, and that's congruent. Could I say that these triangles are congruent? What do you guys think? Do we have enough information to show that these triangles are congruent? We have 4 out of the 6 pieces, right? We're just missing 1 set of sides and 1 set of angles. Can we figure out the other angle?
Yeah.
What is my other angle? 80. Okay, so really now I'm only missing 1 set of sides. Is this going to make the same exact triangle?
No.
Are you guys just saying no because I asked one more time? So what we're going to take a look at today is shortcuts to figure out if triangles are congruent. We know from last class that if I have all 3 sets of sides, corresponding sides, and all 3 sets of corresponding angles congruent, if I had all 6 pieces of information, I could say the triangles are congruent. There's actually 5 shortcut ways where we have 3 specific pieces of information, then we can say the triangles are congruent. So instead of having to show all 6 pieces, these 5 shortcuts will get us there. So these 5 shortcuts are acronyms, just like CPCTC was an acronym. Ooh, who can remember what CPCTC stands for?
Corresponding parts are congruent.
Very close, you've got the correct words, but in the wrong order. So CPCTC, corresponding parts of congruent triangles are congruent. So we have to first have triangles are congruent before I can say that my pieces are congruent. So if I, with this here, if I were to go ahead and call this A, B, C, and X, Y, Z, if I was given that triangle ABC is congruent to triangle XYZ, once I have this statement, then I can make conclusions about my sides and the angles. After I have this statement, then I can say, hey, angle B is congruent to angle Y. My reasoning would be CPCTC. CPCTC. Which says if I have congruent triangles, I know their corresponding pieces are congruent. Okay, so in proofs, we'll be using CPCTC, but you need to first have a statement that says the triangles are congruent. What we're learning today are 5 more acronyms that we use to prove triangles are congruent. So these in a proof probably happen before your CPCTC. Okay, so let's talk about these 5 acronyms. Now these 5 acronyms are technically theorems and postulates, but I'm not going to make you write out theorem postulate for these. You can just use the 3-letter acronym. Okay, our very first method is SSS. This is our side postulate. So this is technically a postulate. But again, on a proof or when it asks you to justify or write the theorem or postulate, you can just write SSS. So what side stands for is that if I have 2 sets of triangles and the corresponding sides are congruent, I can automatically know that the 2 triangles themselves are congruent. See example 1. I have AC is congruent to DX. I have BC is congruent to XK. And then I have side AD is congruent to side DX. 3 sets of corresponding sides congruent, and I can know that these 2 triangles are congruent by side. Alright, so let's go ahead and match this up to triangle ABC. What is A going to match up with? D. And then what does B match up with? Okay. And so C matches up with X. So triangle ABC is congruent to triangle DKX. Okay, so this one's our postulate. If I have corresponding sides congruent, all 3 sets, then I can automatically know that those triangles are congruent. right, our second one is what we call side, angle, side. Side, angle, side. This is technically a pair. The rest are going to be pairs. And notice that our angle is in between the two sides. We call this the included angle, the angle that's in between the sides. So if we take a look at number 2 here, I have a set of corresponding sides congruent. I have an angle, and then the side next to it congruent. So we can see it's the two sides of the angle in between, the included angle. Now notice our picture for number 2 has been flipped across. It's fine. Our pictures will be flipped, they'll be rotated, and they'll try to throw you off with it. Just match up your corresponding pieces. I have a 1 tick mark side, a 1 tick mark side, a 1 arc angle, a 1 arc angle, and a 2 tick mark. 2 tick mark. So I have a set of sides, angle, sides, congruent. So this would be congruent by a side, angle, side. So triangle RST would be congruent to triangle WZX. Do we agree? Now again, make sure you're careful in matching up that information. Let's say, for example, that instead of our picture looking like this, our picture looked like this. These would no longer be congruent by side, angle, side because our angles that are in between are not the same angle measures. Okay, so just make sure you have the same markings matched. All right. Can you guess what our third one might be? ASA, angle, side, angle. It's 2 angles and the side in between, or the included side. Alright, so this is angle, side, angle. You can write out what that is if you want, but I trust that you guys know what A stands for now. This is another theorem. And again, notice our side has to be in between the 2 angles. So I can say that these 2 triangles are congruent by angle, side, angle. Some people lovingly refer to it as A side. Alright. So again, this has been rotated around, so be careful as you match it up. Triangle RST matches up with triangle J. Good catch that J and R go together. As you write your congruency statement, it's good to do a quick double check. I should be able to match up all of my angles and match up all my sides. So I should be able to say, hey, side RS should match up with JL. RS, JL. Uh-oh, did it match? Oh, sorry, RT. RT should match up with JL. So you can do that quick check. A lot of times when students get these wrong, they get back to their assessments, they're like, oh no, I meant to do it in a different order. So writing it out and checking it is going to save you some credit. What did we say? JKL, is that what it was? All right, number 4 and 5 are a little bit different, so I'm going to go ahead and tell you the acronym for these. Number 4 is actually angle, angle, side. This is another theorem. So notice now my set of sides that are congruent are not in between the angles, but rather next to them. Now for number 4, we have this marking indicating that these angles are congruent. But this just means that they're right angles. Do I know that those are congruent? Why? Good. Right angle congruent stand. All right angles are congruent. So I do have 2 sets of angles congruent, and notice my side is next to those angles, not in between. So an angle, angle, side. So they're congruent by angle, angle, side. NZP matches up with triangle WRT. Okay, before we go over number 5, there's something else I wanted to make mention of. So number 4, we call this angle, angle, side, and it is not angle, side, angle. As you're going around with the pieces of information, you want to make sure that you're not skipping or going over a gap of angles and sides. For our angle, side, angle, it has to be the side in between those two angles. You can see here, this is not the side in between those two angles. There's still that angle over there. Also, what's our other one? Side angle, side, it has to be the angle in between. So again, notice our angle is in between those. I would not call, let's see, I would not call this one angle side. We've skipped a couple of sides and an angle trying to go around that way. So you want to go with the ones right next to each other. Now, of course, angle side, you're not going to be hitting the side between. So the angle right next to it, and the side right next to that. Questions on 1 through 5? Okay, so our last one is actually HL. Didn't see that one coming, did you? I'm not making this up, this is real. This is another theorem. Now I want you to put this note underneath. Can only be used with right triangles. So just because it's a right triangle doesn't mean you have to use that one. But if it is a right triangle, that's a possibility. If it's not a right triangle, we can't even consider this one. So thinking of what we know about right triangles, what do you think H and L stand for? Hypotenuse and leg. Very good. So let's talk about what a right triangle is with its anatomy, with its pieces. Right triangle has that right angle. What is my hypotenuse in a right triangle? The longest side, and where's that located? Opposite of my right angle. So this is my hypotenuse. And then these are called legs. For our hypotenuse leg, it doesn't matter which leg. Matches up just as long as it's a leg and hypotenuse. So our first 4 had 3 pieces of information. It looks like our last one only requires 2, but technically there is that third one. We have to have the hypotenuse, we have to have the leg, and the fact that it is hypotenuse leg means it's a right triangle, so it technically has that third piece as well. So let's take a look at example 5. And this would be an example of hypotenuse leg. We see our hypotenuses. Hypotenuses. Our hypotenuses are congruent. We have a set of legs congruent. These are right triangles, so these are congruent by hypotenuse leg. And that would be triangle VNT matches up with CAB. Now notice number 4, even though it was a right triangle, could I use hypotenuse leg for that? Why not? What's missing? The leg. We have the hypotenuse, but we don't have the leg. Okay, so these are our 5 shortcut methods to prove triangles are congruent. Side, 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 angle, side, angle, angle, side, hypotenuse leg. Now, I want you to just watch, listen, and don't talk. Okay. I'm going to put something up here that is not a method. Think, but do not speak. It seems we have every possible combination except this one, right? If we were to read this backward, that would be a bad word. And we don't use that in this classroom. No bad words in this classroom. Now, interestingly, this is actually not one of our methods. Not just because it's a bad word, that's just convenient. I'll show you in a moment why it's one that why it doesn't work. But this does not guarantee that the triangles are congruent. Okay, so this is not a method. I never want to see this written down. If you write it down, you will guarantee you get it wrong, and I might take off extra points because you wrote it down. So no bad words in here. So this is not one of our methods. Okay. Now you'll notice with HL, you'll be tempted to write that. Side, side, angle. But it is not side, side, angle. That is not a method. HL, which is only used here. So let's talk about why the bad word does not work. Look to your very back page. Okay, so here's an example of the bad word. Now, it's possible that these triangles are congruent, but it doesn't guarantee that they are, which is why we can't use it. So this would be where the triangles are congruent, right? It looks great, it looks perfectly fine. But it could have been, instead of this scenario, instead of our side swinging this way, keeping that same length, our side could have been over here. Notice I did not mess with any of the other given information. This side length stayed the same. This angle stayed the same. This side length stayed the same. But because there was no angle, nothing known about the angle here, nothing known about the angle here, and nothing known about our bottom line, it has the potential to be a completely different triangle. So that side-side angle does not guarantee that the triangles are congruent because it's actually possible for it to have been this triangle instead. So they could be congruent, but we don't know for sure. So we have insufficient information to determine that they are. So this is why bad word does not work. So it's easy to remember it doesn't work because it's a bad word, but mathematically speaking, this is why. Questions with that? When you get to pre-calculus, should you decide to take that, you're going to use law of sines, law of cosines, and when you encounter this type in our law of cosines, you have to decide whether or not it makes one triangle, two triangles, or no triangle. So that's complicated. But still, it does not guarantee that they're congruent, so we have to say not enough information. Okay, questions with that? While we're here, let's go ahead and talk about the rest of these. So these are examples of triangles with insufficient information. All right, this first set here, we have angle, 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 angle. I want you to turn and talk to your shoulder partner for 30 seconds. Why does this not guarantee that they're congruent? Wait, it seemed like it took you guys 15 seconds rather than 30 seconds. Who would like to volunteer? Why does it not guarantee that they're congruent? Okay, it doesn't say anything about the sides, just about our angles. So what could happen to them? Instead of being, so what would we call them if the angles are the same but our sides are different lengths? It could be isosceles, doesn't have to be though. Could be scaling, doesn't have to be. It's when it's bigger. What would we call that if it's the same shape at different sizes? Zoomed in. Mathematically speaking? Ooh, you're very, 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 very close. Okay, you're thinking along the right lines, we're almost there. Similar shapes, right? Same shape, different size. Yes, does that sound familiar?
Yeah.
Okay, some of you guys are still staring at me. So the example I like to use for this is let's consider an equilateral triangle. What do we know about an equilateral triangle? What do we know about they're correct, the sides are the same. What do we know about the measures of the equilateral triangle? They're all acute? They're all the same? What are they? 60 degrees. So would you agree that for these two triangles, the corresponding angles are congruent? But are our sides congruent? So these would be an example of similar triangles instead of congruent triangles. And in 2 chapters, I think it's 2 chapters, we're going to talk about similar triangles. So having all 3 angles congruent actually shows similarity, not congruency. So similar triangles don't know if congruent. So we would have to have something about our sides to know that those are congruent. All right, what about our second set of triangles over here? What's the issue? What are we missing? A leg, yeah. So these say triangles with insufficient information, so we don't have enough information here. We have our hypotenuse. We have it's a right triangle, but we need a leg. So no legs congruent. Okay. this guy was the bad word. But what that means is could be two different triangles. What's our problem with this last set here? We have two sets of congruent sides, and we have an angle that's congruent. They're not the same yet. It's not the same location. Here I have the angle is the included angle, so it's in between those sides. Here it's the angle next to it, so it has to be that same location. So different locations. Right, questions with these four scenarios? Okay, so let's go ahead and go back to the inside of our notes and just look at different examples. So this is the idea of what we're doing today, these 5 methods. We're just going to take a look at a bunch of examples and other pieces of information that we might be able to use to help us answer these. Alright, so looking at the page, triangle sharing a common side. So sometimes we can add more information to our picture because they are triangles that are next to each other and they share a side. So for this first one here, they've gone ahead and drawn it in, but we can see that these two triangles share this. So this is going to be congruent to itself, right? It's the same length for the left triangle as it is for the right triangle. What is that property that lets me say that segment or side WM is congruent to side WM? Reflexive. And you'll find that we use reflexive quite a bit in our proofs for this unit. Alright, so what would be the method to prove these congruent? Ooh, that was fast. Who said that? Was that you, Nathan? That was like, good. So by side, side, side. Alright, so we have triangle TMW. It's congruent to triangle XMW. Not BMW. X. Okay. Let's take a look at our next one. Again, another example where these triangles share this side. So, can we prove these triangles congruent yet? Yeah. Angle, angle, side, angle, angle, side. So by angle, angle, side. Again, make sure you're careful with which pieces you match up. Triangle ABC is congruent to triangle ADC. ADC. Not ACDC. Okay. Our next set. We currently don't have enough information. We only have one set of sides and one set of angles. What else do we know?
HL.
They share this. And what method can we use?
HL.
HL, very good. Hypotenuse and a leg. Alright. You have to be very careful with this. NQK matches up with MNK, KNN. Which one is it? So we want to make sure that, let's take a look. NQ. What should NQ match up with? KN, yeah. So NQK matches up with KN. So again, that's why it's really good to do just a quick check afterward. I should see NK matches up with KN. Okay, KN, good. MQ we already checked. QK should match up with NN. QK. So again, please do that quick check so that you don't make a simple mistake. Alright, what do we have about our second picture here? What do we know? They're parallel. Do I have any of the sides are congruent?
No.
Yes? No? Maybe so?
Yes. The one they share.
Yes.
Yeah. Yeah.
I'm getting mixed signals here. If I have parallel lines, are they congruent?
No. Yes.
Yeah.
Yes.
Are those congruent?
Yes.
These right here?
Yes.
Those are congruent.
No.
No, these are not congruent.
They're not the same size.
Okay. So parallel doesn't automatically mean that they're congruent, okay? So every year I have students that see this and automatically assume that that means that those are congruent. Not always the case. We know that they're parallel. So let's use what we know about parallel lines. Oh, wait, what? What we learned just last unit comes back again? Yes, it never goes away. All right, parallel lines. Transversal, what could I say? What was that? Alternate interior angles for the wind. Alternate interior angles are congruent there. Sweet. Now, if I try to do my other alternate interior, that would include something outside my triangle, so that's not going to be beneficial for us. So what else could we do? The other parallel lines. We have these parallel lines. We're so lucky they gave us two sets. That's not always the case. They don't automatically assume it. So now I can say that these are congruent. Remember, you're going from your transversal to your parallel line. We'll be fine. Okay. Now what? I've got two sets of angles. What's the side we're talking about? Yeah, they share that side. So now I have angle, side, angle, angle, side, angle. Notice again, you have to match up the one arcs together and the two arcs together. Okay, so we can say these are congruent by angle, side, angle. RBF, what is that going to match up with? EBF or EFB? EFB. So RBF, we went one angle to the two angles. We have to go one angle to two angles. EFB. I promise you, I will give you problems where it flips it around like that. So just because they share the same letter does not mean it's going to be in the same location. We can see that up here, C stayed in the same location, right? A stayed in the same location. But for these ones, our K moved around, our M moved around, our T moved around, the F. Okay, go ahead and do this last one, and then double check with your shoulder partner that you have the same reasoning and the same congruency statement. Alright, do you guys agree with what's up here on the board?
Yeah.
Awesome. Questions so far? Okay, let's take a look at our next page. Again, still those same 5 shortcuts, just different types of geometry. Alright, so for this first one, with our triangle CMD and our triangle AMD, we have 2 sets of sides congruent. It's not quite enough. What else do we know? John?
There are
Good, we have vertical angles. It's not that they share an angle, but that they have vertical angles. Vertical angle theorem tells us these are congruent. So this bow tie here, these triangles are congruent. What's my method?
SSA. SAI.
You almost committed the crime. That was close. Side angle side. Okay, so we know this by side angle side. Now notice here, the statement is not written out for us at all. So what you write down might be different than your shoulder partners when you're doing your homework, but as long as the corresponding letters match up. I'm going to go with CMD. And that would then be AMD. Okay. So as I'm grading your quizzes and your tests, I'm literally checking every single set of letters on every single person's test, on every single problem that they match up. C and A match up, M and M match up, D and B match up. All right, next one. What do we know here? We got parallel lines again. So what can I say for my parallel lines? What's that? We also have vertical angles, yeah. Okay, so let's start with the parallel lines since that was the first thing we said. What angles can we say are congruent from our parallel lines?
You and I.
You
You and I? Alright. And then Tara said we also know vertical angles theorem. So what method can we use here?
Angle.
Angle, side, angle. Okay. What if we didn't use our vertical angles? Could I say something else other than just that?
It's you know.
T and what?
R.
How do we know T and R?
Parallel.
They're another set of alternate interior, right? Just a different transversal. So what would this method be?
Yes, sir.
Angle, angle, side. We can't say angle, side, angle because that has to be the side in between them. I would need the angle over here for it. So there's actually two methods for this. You'll find that in our proofs. A lot of times you can do them in a variety of ways. And so once again, I'll be checking within your proof. If you would have done angle, side, angle, I would have been looking to see that you said you and I were congruent. If you did angle, angle, side, I would have been looking to see that you had both of these congruent. You could have even done angle, angle, side if you would have done your vertical angles, and then R and T. That would have still been angle and side. Okay, so let's match this up. Let's go tum. What does TUM match up with? Which one is it? What matches up with T? R matches up with T, right? So TUMRIM. And again, let's double check. I know that this side UN matches with NI. So I should see UNNI. Yep. Okay. Now we get to have overlapping triangles. So overlapping triangles, sometimes, most times, it's in your benefit to redraw them separately. Pull them apart and redraw them and then fill in our information. This tick mark is saying that SR is congruent to ST. In our geometry class, the tick marks represent from point to point, always from point to point. If I wanted to show that SQ was congruent to SU, I would have had to write a separate statement stating that. Because our tick marks always go from point to point. Alright, so what that looks like on our diagrams over here. So it's ST, which is this, is congruent to SR. And we also have Q and U. That was the information given to us. Alright, we've only got two pieces. What else do we know? Angle S, they share angle S. So angle S is going to be the same for both of these. Good. So now what method do we use?
SAA.
Angle, angle, side. Angle, angle, side. And let's go with STQ. Matches up with
SRU.
SRU. I know that we ourselves are not writing the triangle, but make sure that on your homework, on assessments, you do have that triangle to indicate that. Okay. Other questions? I want you guys to go and try this last one on your own. And again, you'll check it with your shoulder partner. Did you use the same method? And do your letters match up? They don't have to be in the exact same order as your shoulder partner, but the corresponding has to match up. Okay, did you guys get angle, side angle for this? Okay, what did you get matches up with H? On your other statement, what matches up with H? F, good. What matches up with I? And what's your last name? Okay, questions on that? Okay, we'll clear the back side, bottom of the page. I want you guys to try these 9 on your own. So state the method used to prove that triangles are congruent. If there's not enough information, then write not enough info. You are welcome to work with your shoulder partner on these 9. Give you a couple minutes for those, and we'll go over that.
That one would work. This one. No, on 4. Like it seems like all the other ones.
So, our methods here. Our options would be this or that. Those are the 2 sides. This or that. Now, this is the angle that has to be, and these are the 2 sides. Okay.
Aiden, number 1, because
So
the angle flips from
in between the sides. Here, my sides in between. Okay. Side, side. We would not say angle side.
this one you don't get either. Wait, it's not side side side.
Our side is next. Now, what from the same person is that it's not
Because there's a equal sign and there's also another
So right now we can use any of them. But this so this like this awesome.
Is there side
Is there what?
you could, but if we do this on a tab, it's something you guys decided to yeah.
Like that's
Because the parallel is
This bottom line doesn't translate.
they could be compared, but we don't have them.
Wait, is this?
Could I have a volunteer to write up their answer for 1, another volunteer to write up their answer for 4? Yep, you can go that way, and another volunteer for number 7. You can just go another, and maybe I'll start calling on you. What else you guys saying?
Let's see. I'm gonna do 7.
I'm gonna ask Paige. Hey, Johnny, you're just
Yeah.
Very first.
I'm sorry, I'm so sad.
Yeah, so you could say just no. No, his friends do.
Casey, you should write the wrong. Leave Angel Screen number 1.
Number 1?
Number 1, probably. Casey, which one are you doing? 4. Katie and I probably, but since each one is a transversal, these ones and these ones with just the angle side. Okay.
Okay, so before you say how do you know that one is a reason?
Because these lines are parallel, and then this is a transversal. And the same thing with these. Transversal. You need if you like increase the line.
Can I have volunteers for 5 and 8? We'll go over these. We need to scroll down more. We've got it. No need to be upset. Alright, we need to write at 5, and then we need whatever those ones are. 3, 6, 9.
Do it.
What should I do?
6. Let's see what I'm writing.
That's why I'm constantly going back and forth. I was doing it 2 for 1.
No, it's on that one.
I'm taking this. Alright, I need number 5.
I'll do it.
I'm gonna do the angle.
Oh, it's blue now.
Okay, let's see if we agree. Number 1, do we agree?
Yeah.
I agree. We have a set of 2 sides and a set of 2 sides, and we have a set of angles, but the angle's in the wrong location. It has to be in between in order for it to be safe. Or this could have been moved over there. Yeah, so not nothing but good. Number 4, do you guys agree?
Yes.
As well. Number 7?
Yes.
Yes, good. Number 2?
Oh, no. Yeah.
Do we agree?
Yes.
I agree. We only have this additionally. That's only one set of angles and one set of sides, right? We don't have enough beyond that. All right, how about number 5? Do we agree?
Yes.
Good. Number 8, do we agree?
Yes.
Yes. It's the backwards. Okay, number 13, do we agree?
Yes.
And 6?
Yes.
And number 9?
Yes.
Yes. Okay, let's talk about number 6. It does look like a This one kind of looks like a big piece. All right, so number 6, let's talk about this. Or rather, I want one of you to explain. How do we know number 6 is angle side case? Corresponding angles postulate. So we have this set of parallel lines. But this is my transversal. Corresponding angles are congruent. And then repeat. We have another set of parallel lines. But this is my transversal. Corresponding angles postulate. So parallel lines, a lot of times we use alternate interior, but we can use the other ones as well. Alternate interior and corresponding angles is fine. Okay, any questions with these? Sure. Number 8. So this would be the backward one. It's an angle side side. Angle side side, which we can't say. Other questions or other ones that we need clarification on? Yes. Number 5. So even though it's been flipped around, we have 1 tick mark, angle in between, 2 tick marks. So if I were to rotate this background, it would match up with it. So don't let the picture fool you, just look at the information given to you. Are there others that we need clarification on type questions? Yes or no?
How does corresponding number 6 give us?
So we have 2 sets of angles there. Does that make sense how we got the angles? And then they gave us the side in between.
Oh.
So angle side, angle, angle side. They gave us that side. Yes. What's what? Between 5 and 8. So here we have side and angle side. The angle is in between. Here my angle is not in between, which gives us angle side side, which is the bad one. If this would have been in between, we would have been fine. Oh, that's a good question. So, if Sarah asked, if we wrote angle, angle, side, or side, angle, angle, does that matter? I'm okay if you go backwards. It's just going to look really weird. You'll always see me write it in this method, but if you do side, angle, angle, that's fine. Just never write side, side, angle, or angle, side, side. We have these angles. What other angles do you think you have? Yeah, that's all we have, so that's why we don't have that. It has to be within 1 triangle. Alright, other questions on those? Okay, listen up. Vote should still be off and away. Who else am I gonna go? Okay. Look at your assignment sheet. What's happening next class?
Quiz.
What is your homework tonight? Worksheet 3 and 4. It is 2 different pages, but as you can see, they go really quickly.
Did you write SQ?
No. It's worth a shot. Now we're just trying to go too creative.
Seniors, do you need help filling out your college application? What a second.
Guys, listen up to the announcements, please.
School counselors will be available for college application questions.
In order, make sure you wear black tomorrow. Blackout bullying. It's anti-bullying day at Franklin. And also, we have the football game tomorrow night. Also at County against South Lake. One final thing, Mr. Hurt is Monday, November 19th. Question, see the score at 3209. Thank you, Ordinance, and have a nice day.
And this is going to be different, like, quadrilateral. That one works.
Make sure you have 2 pages, 3 and 4. You're not going to both read it.